My name is Purnima PM and I'm working as a maths teacher in Vedavati Girls High School. In today's class, we are going to take up the first chapter of 9th standard, that is number system. Okay children, in your earlier classes you have studied about the numbers, isn't it? Yes, 1, 2, 3, 4, 5, these are called as the numbers. Okay, in these numbers we are going to study about the natural numbers, whole numbers, integers and rational numbers. Okay, so we will take up one by one. First we should take up natural numbers. Natural numbers. Okay, what do you mean by natural numbers, children? I think you are studying 5th and 6th, isn't it? Okay, now tell me what do you mean by natural numbers? Yes, the counting numbers 1, 2, 3, 4, 5. It goes on like this. So the counting numbers 1, 2, 3, 4, 5 are called as natural numbers. Okay. So natural numbers means the counting numbers 1, 2, 3, 4, 5 are called as natural numbers. Okay, so now we got the meaning of natural numbers, isn't it? So we are going to denote these natural numbers by capital letter, children. Yes, that is n. So the natural numbers are denoted by n. So natural numbers can be denoted by a capital letter, that is n. So we can write these natural numbers in the form of set, that is n is equal to 1, 2, 3, 4, 5. We can write up to any numbers which is infinity, countless. We can write 1,000, crores like this. Okay. So the counting numbers are called as natural numbers. So next we shall move on to the next one, that is whole numbers. Whole numbers. Okay, what do you mean by whole numbers? Now we got the meaning of natural numbers, isn't it? Okay, now tell me what's the meaning of whole numbers? So in natural numbers, we'll start from 1, 2, 3, 4, 5, isn't it? Okay, so in the case of whole numbers, children, it starts from 0, 1, 2, 3, 4, 5. So the natural numbers including 0 is called as whole numbers. So the natural numbers including 0 is called as whole numbers. So the difference between natural numbers and whole numbers is, children, in natural numbers there will be no 0, whereas in the case of whole numbers there will be a 0. So the natural numbers including 0 is called as whole numbers, and the whole numbers are denoted by a capital letter W, children. So whole numbers are denoted by capital letter W. So it can be written as the natural numbers including 0 are called as whole numbers, and the whole numbers are denoted by capital letter W. So all numbers are denoted by capital letter W, and in the set form it can be written as W is equal to 0, 1, 2, 3, 4, 5. It goes on like this. So these are called as whole numbers. So just In natural numbers and in whole numbers, there is only one difference. That is, in natural numbers there will be no zero, whereas in the case of whole numbers there will be a zero, children. Got it? So next we should take up integers. So the next one is integers. Okay. So far we have studied about the natural numbers, whole numbers. Now we are going to take up integers. Now what do you mean by integers? Okay. Just see the natural numbers and whole numbers, children. Is there any negative numbers here? No. So in natural numbers and whole numbers there is only positive numbers. Whereas in the case of integers, children, there will be positive numbers as well as there will be a negative numbers. So integers includes positive numbers, negative numbers, and also zero. So this set including zero, positive numbers as well as negative numbers are called as children integers, and these integers are denoted by a capital letter Z. So integers are denoted by capital letter Z, and it can be represented in the form of set as 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4 dot. Like this we can represent the integers in the form of a set, and it can also be written as minus 4 minus 3 minus 2 minus 1 0 plus 1 plus 2 plus 3 plus 4. So I hope you got the meaning of integers, isn't it, children? So integers are the numbers where it includes negative numbers, positive numbers as well as 0. Okay. So now we shall move on to the fourth one, that is rational numbers. Okay. Rational numbers. So, rational numbers means, children, the numbers which are expressed in the form of P by Q are called as rational numbers. So, the numbers expressed in the form of P by Q. The numbers expressed in the form of P by Q, where P and Q are integers, where P and Q are integers, and Q should not be equal to 0. Q should not be equal to 0 means, children, the Q value should not be 0. It should start from 1, 2, 3 like that. Understood? So, see the definition once again. The numbers expressed in the form of P by Q, where P and Q are integers. Integers means, children, you know that integers there will be a positive numbers, negative numbers as well as 0, isn't it? And Q should not be equal to 0. Now, rational numbers are denoted by a capital letter Q, children. Rational numbers are denoted by capital letter Q. So, rational numbers are denoted by Q. Okay, now we know that the numbers which are expressed in the form of P by Q are called as rational numbers. So, now I will write some examples just here. 2 by 5 minus 4 minus 3 by 5 P by Q. So just see the first number, that is 2. So 2, it is not in the form of just P by Q, isn't it? Okay, see, you can ask me a question, ma'am, in denominator nothing is there. So in denominator nothing is there means we are going to consider that as a 1 children. So we will take 2 as a 2 by 1. So the value of P is 2 now, Q is 1. So 2 is also an example for a rational number. See the second one, 2 by 5. P value is 2 and Q value is 5. Third one, minus 4. Just see here. So rational numbers includes integers. Integer means it may be a positive number as well as negative number. So in the numerator it is minus 4. If nothing is there, it means you consider that as a 1. So minus 4 by 1 is also a rational numbers. Minus 3 by 5, 6. So all these are an example for a rational numbers. And it can be written as in the form of set. Q is equal to 2 by 1, 2 by 5, minus 4, minus 3 by 5, 6. So these are all the examples for rational numbers. Okay, children, I hope you understood the meaning of rational numbers, isn't it? Okay, so far we have studied about the natural numbers and whole numbers, integers and rational numbers. Okay, once again I will repeat all the things. Natural numbers means, children, the counting numbers are called as a natural numbers. And natural numbers is denoted by a capital letter N. And the second one is whole numbers. The counting numbers including 0 is called as a whole number and it is denoted by a capital letter W, and it can be written in the form of a set. W is equal to 0, 1, 2, 3, 4, 5, etc. And the next one is integers. Integers means it includes positive numbers, negative numbers and also 0. And it is denoted by a capital letter Z. So it can be written as Z is equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, dot, dot, dot. So the next one is, children, rational numbers. Rational numbers means the numbers which are expressed in the form of P by Q are called as, where P and Q are integers and Q should not be equal to 0, are called as a rational numbers. Examples 2, 2 by 5, minus 4, minus 3 by 5 and 6. I hope you have understood all the numbers, isn't it? Natural numbers, whole numbers, integers and rational numbers. Now we should move on to the exercise problems, children. We take it one by one. Okay. Children, now we shall see the exercise problems. That is exercise 1.1. The first problem is 0 is a rational number. Can you write in the form of P by Q, where P and Q are integers and Q is not equal to 0. Okay. So here they are asking whether 0 is a rational number or not. Okay. So already we have studied about the rational numbers, isn't it? What do you mean by rational numbers? Yes, rational numbers means the numbers which are expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Okay, we take some of the examples, children. 0. Okay. If nothing is there in the denominator, we can write it as 1, isn't it? 0 by 1, 0 by 2, 0 by 3, 0 by 4, 0 by 5. Okay. So here 1, 2, 3, 4, 5 are positive numbers. In the same way, we can write it as 0 by minus 1, 0, nothing is there means minus 2, 0 by minus 3, 0 by minus 4, 0 by minus 5. Okay. See the both the example. 0 in denominator 1, here 2, 3, 4, 5. Here minus 1, minus 2, minus 3, minus 4 and minus 5. So what is the condition in rational numbers? That is Q should not be equal to 0, children. They are not telling that P should not be equal to 0. P may be 0. But the thing is, in the denominator, they should be not be 0. They should not be 0. number. So 0 is a rational number. Got it, children? So in rational numbers, numerator can be 0, but the denominator should not be a 0. So 0 can be written as 0 by 1. So we can consider that 0 is a rational number. I hope you understood, isn't it? Okay, shall we move on to the second one? Yes. See, second one, what is that? Find 6 rational numbers between 3 and 4. Find 3 rational numbers between 3 and 4. So now we have to write the rational numbers written between 3 and 4. So how to write? Let us see. Okay. So we should take up first one, that is 3. So for 3, multiply 7 for numerator as well as for denominator, children. For numerator also multiply by 7 and for denominator also multiply by 7. So when you multiply 7 to the numerator, what do you get? 3 sevens are 21. 7 ones are 7. So what do you get? 21 by 7. Isn't it? In the same way you take second one, that is 4. For 4 also, if nothing is there, means what we are going to consider? 1. So for 4 also multiply by 7 for numerator as well as for the denominator. 7 by 7. 7 4s are, yes, 28. So 1 into 7, 7. Okay, so 3 we get as 21 by 7 and for 4 we got as 28 by 7. Now we are going to write the 6 rational numbers between children, 21 by 7 and 28 by 7. So we can write it as, so first is 3, no, we write it as 21 by 7. So now we have to write 6 numbers, 22 by 7, 23 by 7, 24 by 7, 25 by 7, 1, 2, 3, 4, 26 by 7, 27 by 7, and the last number what they given, that is 28 by 7. See children, these are the 6 rational numbers between 21 by 7 and 28 by 7 means 3 and 4. Therefore, the 6 rational numbers between 3 and 4 is 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. So these are the 6 rational numbers between 3 and 4. Did you understand, children? Okay, once again I will tell you. So we have to write down 6 rational numbers between 3 and 4. So for this what we are going to do is, so for first 3 we are going to multiply 7 for numerator as well as for the denominator. So 3 sevens are 21 and 1 sevens are 7. So we will get 21 by 7. In the same way, for 4 also we are going to multiply by 7, that is 4 sevens are 28 and 1 sevens are 7. So we got 21 by 7 and 28 by 7. Now we have to write the 6 between 3 by 5 and 4 by 5 children. So now we have to write the rational numbers between 3 by 5 and 4 by 5. Okay, here also we are going to do the same steps. Take the first one, that is 3 by 5. Second number is 4 by 5. So here we are going to multiply the numerator and denominator by 6 children. So we are going to multiply by 6. 3 6 are 18. 5 6 are how much? 5 6 are 30. Yes. In the same way, for this also multiply by 6. 4 6 are 24. 6 5 are 30. Okay, now 3 by 5 we have written as 18 by 30 and 4 by 5 we have written as 24 by 30. So now we have to write the 6 rational numbers between these two numbers. Okay. So 18 is there. First number is 18 children. 18 by 30. Let it be like that only. So now we are going to write next number. 19 by 30. 20 by 30. 21 by 30. 22 by 30. 23 by 30. How many numbers children? 1, 2, 3, 4, 5, 6, isn't it? The last number is 24 by 30. So we have written 5 rational numbers children, not 6 rational numbers. So we got here 5 rational numbers, that is 19 by 30, 20 by 30, 21 by 30, 22 by 30 and 23 by 30. Therefore, the 6 rational numbers between 3 by 5 and 4 by 5 are children 19 by 30, 20 by 30, 21 by 30, 22 by 30 and 23 by 30. Okay, you understood? Okay, once again I repeat. We have to multiply 3 by 5 by 6 by 6. So we will get 18 by 30 and 4 by 5 by 6 by 6. We will get that 24 by 30. Now we have to write down 5 rational numbers children between 18 by 30 and 24 by 30. Not 6, 5. So those are 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. You understood? Okay. Shall we move on to the fourth one? So the fourth one is children. State whether the following statements are true or false and give reasons for your answers. So we take up the first one, that is every natural number is a whole number. A very natural number is a whole number. Okay, in the starting of the class we have studied about the natural numbers and whole numbers, isn't it children? So in natural numbers we will be having 1, 2, 3, 4, isn't it? Whereas in the case of whole numbers 0, 1, 2, 3, 4. Okay, what is the question? Every natural number is a whole number. Just see the whole number set. So here all the natural numbers are present now? Yes, all the natural numbers are there and also 0 is there. So in the whole numbers, all the natural numbers are going to present. So the given statement is true children. So the given statement number, this statement is true because whole numbers includes each and every natural number. Understood? Okay. See the next one, children. Every integer is a whole number. Second one. Every integer is a whole number. Okay, whole numbers means children 0, 1, 2, 3, 4, dot dot dot, isn't it? Okay, integers means 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4. So, whole numbers starts from 0, 1, 2, 3, 4. Just see the whole numbers set, children. In whole numbers, only positive numbers are present. There is no negative numbers. Whereas in the case of integers, children, positive numbers are also there, negative numbers are also there. So now tell me whether the statement is true or false. Yes, the statement is false because every integer cannot be a whole number. Because whole numbers does not include the negative numbers. Therefore, we can say that this statement is false. This statement is false, children, because integers includes positive numbers as well as the negative numbers, whereas in the case of whole numbers, we are having only positive numbers. Got it, children? Okay. Children, now we have solved two problems. The third one is every rational number is a whole number. Every rational number is a whole number. Okay. So already we have studied about the rational numbers, isn't it? So rational numbers means the numbers which are in the form of P by Q, where Q is not equal to 0 and P and Q belongs to integers, isn't it? And whole numbers means the natural numbers including 0, 1, 2, 3 are called as whole numbers. See the statement what they are given. Every rational number is a whole number. So for rational numbers, we'll take some of the examples such as 2, 3 by 5, 6 and 2 by 3. Okay. See the first one 2, isn't it? If nothing is there means we'll consider 2 as a 1. Now 2 and 2 by 1. 2 is a whole number. 2 by 1 is a rational number. See the third one 6. 6 means if nothing is there means we'll consider that as a 1. 6 is a whole number and 6 by 1 is a rational number. See the second one, children, that is 3 by 5. So it is in the form of a fraction, and the fourth one is 2 by 3. So it is also in the form of a fraction. These two are not a whole numbers. So from this example what we can conclude that every rational number is not a whole number, because in whole numbers we are not going to have a fractions. So in whole numbers we will be having 2, 3, 4, 5, 6. So therefore every rational number is not a whole number. Is not a whole number. Okay, did you understand, children? Because rational number means there will be a numerator as well as a denominator. So there will be a fraction, whereas in the case of whole numbers there will be no fraction. So from this we can conclude that every rational number is not a whole number. Did you understand? Okay, so children, we have completed this exercise, that is 1.1. So far we have studied about the natural numbers, whole numbers and integers and rational numbers, and we have solved the problems also, isn't it? Okay, so just once again I will revise. Natural numbers means the counting numbers including 1, 2, 3, 4, 5 are called as natural numbers. Natural numbers are denoted by a capital letter N. So next is whole numbers. Whole numbers means the natural numbers including 0 are called as whole numbers, and the whole numbers are denoted by a W. And the next is integers. The integers are the numbers which includes positive numbers as well as negative numbers and also 0. And integers are denoted by a Z, capital letter Z. And the next one is children, rational numbers. The numbers which are expressed in the form of P by Q, where Q is not equal to 0 and P and Q belongs to Z. So this is about the rational numbers, children. So we have completed the exercise 1.1. Shall I give some more problems for the homework? Okay, write on. Write on, children, first one. Write the six rational numbers between 2 and 3. So write the 6 rational numbers between 2 and 3. Next is, children, next is write the five rational numbers between 2 by 7 and 3 by 7. So this is the homework. You have to write and come tomorrow. Got it? Okay. So far we have studied about the numbers, isn't it? So the next one is, children, irrational numbers. So we have studied about the rational numbers, isn't it? Okay, then can you tell me what do you mean by irrational numbers? Irrational numbers. Irrational numbers, children. Irrational numbers. So the numbers which cannot be, listen properly, which cannot be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. So listen carefully. The numbers which cannot be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Rational numbers means which can be expressed in the form of P by Q. Irrational numbers means which cannot be expressed in the form of P by Q. So these numbers are called as irrational numbers, children. Irrational numbers are denoted by IR, children. IR. Irrational numbers are denoted by IR. Now we shall see some of the examples for irrational numbers. √2, √3, √5, √7, pi. It goes on, children. So these are the examples for irrational numbers, means √2, √3, √5, 7, root 11. So the numbers which will be not having the perfect square, no, they are called as an irrational numbers. In the set form, it can be written as IR is equal to root 2, root 3, root 5, root 7 and pi. Okay. So, I hope you understood the meaning of irrational number, isn't it? So, the numbers which cannot be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. So, this is about the irrational numbers, children. Okay. So, now we have learned the meaning of irrational numbers, isn't it? So, the last one is, children, last one is real numbers.
Go.
Okay, children. So we have studied about the irrational numbers. Now the last one is real numbers. Real numbers. Real numbers. So the first one we have studied is natural numbers, isn't it? Natural numbers means n is equal to 1, 2, 3, 4, ... So the counting numbers are called as a natural numbers. Next is whole numbers, children. That is 0, 1, 2, 3, 4, 5. And the next one is integers. Integers 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. And the next one is rational numbers. 2, 3 by 5, 2 by 5, 4, minus 2, minus 5 by 6. And the last one we have studied is irrational numbers. Irrational number example is root 2, root 3, root 5 and pi. Natural numbers, whole numbers, integers, rational numbers and irrational numbers. So real numbers means, children, so under the real numbers all the numbers are going to include. So in real numbers what we are going to get? All the numbers will include, children. Real numbers are denoted by a capital letter R. So the combination of all these numbers are called as an real numbers. So in real numbers we will be having natural numbers, we will be having whole numbers, integers, rational numbers and irrational numbers. So it can be written as 0, 1, minus 2, minus 5, 2 by 3, 5 by 6, root 2, root 3. So the combination of all the numbers is called as an real numbers, and the real numbers is denoted by a capital letter R. Did you understand, children? Okay. So just now we have learned about the irrational numbers and the real numbers. In our next class, we are going to study how to represent the real numbers in the number line. Got it? So in the next class, we will learn how to represent the irrational numbers in the number line. Thank you, children.